This is Math 8, Section 2.2, Adding and Subtracting in Scientific Notation. We're going to add and subtract numbers in scientific notation with the same power of 10. So here is our problem. A popular social networking site has the most members between ages 15 years old to 28 years old. Sounds like Instagram. So within this age group there are 5.11 times 10 to the 7th student members and 9.55 times 10 to the 7th non-student members. So within this age group we have these two things, these two amounts. So we want to find out what is the total number of students in this age group. Total number of members in this age group, sorry. So let's take student plus non-student. And the student, we have 5.11 times 10 to the power of 7. Non-student, 9.55 times 10 to the power of 7. Now we can factor, because these are together and these are together, we can factor out this from each. So to factor, we will put these two things together. So we could say 5.11 plus, because there's a positive sign, plus 9.55. We take out the 10 to the power of 7 from each, because both are multiplied times 10 to the power of 7. And that is equal. Now let's solve for what's inside. What's inside is 14.66 times 10 to the power of 7. Is this scientific notation? No, because 14 is greater than 10, so we need to convert. How we can convert that is we could say 14.66 times 10 to the 4th equals, well, this is 1.466 times 10 to the power of 1, because we move to the left 1, times 10 to the power of 4, because we have power of 4 here. So let's simplify. 1.466 times 10, 1 plus 4, remember we add them when they're being multiplied. Oh, times 7, sorry. So that gives us 1.466 times 10 to the power of 8. And that's your final answer. So that is our sum. Now, suppose you want to find out how many more non-student members there are than student members. So we know how many total there are, but suppose you want to find out how many more. You would subtract. How many more non-students? So we're going to subtract 9.55 times 10 to the power of 7 plus 5.11 times 10 to the power of 7. If it helps you to show these in parentheses, show multiplication as first, you may do that. But let's take out the 10 to the power of 7 in each. Sorry, this should be minus, not plus. So inside we have 9.55 minus 5.11, all to the power of 10 to the power of 7. So subtracting, that gives you 4.4 times 10 to the power of 7. This is yes, that is scientific notation. So we can box it. That is our answer. That's how many more non-students. This is total. This is how many more non-students. Okay? So there are this many more non-students. There should be another 4 there. Okay. Example 6. Example 6 says, as of the 2010 census, the population of Wyoming was approximately 5.63 times 10 to the 5th. And that's Wyoming, a state that we have. I visited there this summer. And the population of Vermont was 6.25 times 10 to the 5th. That's Vermont. I've never been to Vermont, unfortunately. So let's find the total population. Okay, to do that, we're going to add the two populations of Wyoming plus Vermont, which is going to be 5.63 times 10 to the power of 5 plus 6.25 times 10 to the power of 5. Now let us take out that 10 to the power of 5. So it becomes 5.63 plus 6.25 all to the power of, all multiplied times 10 to the power of 5. Inside you get 11.88 times 10 to the power of 5. Is this scientific notation? No. So let's convert. It becomes 1.188 because we go to the left this way. It's just 1 0, so it's only 10 to the power of 1 times 10 to the power of 5. Simplify. 1.188 times 10, 1 plus 5 equals 1.188 times 10 to the power of 6. Is that in scientific notation? Yes, it is. Let's do B. B says, find the difference in population. So we're going to do Vermont because there's more, minus Wyoming because there's less, and that is going to give us 6.25 times 10 to the power of 5 minus 5.63 times 10 to the power of 5. This is going to give us 6.25 minus 5.63 all to the power of, all multiplied times 10 to the power of 5, which is 0.62 times 10 to the power of 5. Is this in scientific notation? No. So let's put in scientific notation. We need to go to the right one, which means it will be 6.2 times 10 to negative 1, because we needed to move it to the right, so it becomes negative power, multiplied by 10 to the power of 5 equals 6.2 times 10 to the power of negative 1 plus 5, which equals 6.2 times 10 to the power of 4. Notice our number got smaller. Okay, that is a difference in population, not that. Go ahead and try guided practice 1. Let's work together on example 7. I'm going to try this again. Add and subtract very, very small numbers in scientific notation with the same power of 10. So before we had these really big numbers, here we're going to have some really little numbers. So a CD is 1.2 times 10 to the negative third meters thick, and a jewel case is about 5.3 times 10 to the power of negative 3 meters thick. So let's find out here what is the total. So we're going to add them. 1.2 times 10 to the power of negative 3 plus 5.3 times 10 to the power of negative 3 gives us 1.2 plus 5.3 times 10 to the power of negative 3 gives us 6.5 times 10 to the power of negative 3 meters. Make sure you include your units on the end there. And that is our answer. This is in scientific notation. Yes, you can check that off. You're good. B, let's find the difference. We're going to put the biggest one first. And so it is 5.3 times 10 to the negative third minus 1.2 times 10 to the negative third equals 5.3 minus 1.2 times 10 to the negative third equals about 4.1 times 10 to the negative third meters. Different? Is that scientific notation? Yes, you are good. Go ahead and try guided practice 2. Add, subtract numbers in scientific notation with different powers of 10. So before they all had the same powers of 10, now we're going to get a little bit more fancy. They have different powers of 10. So in this picture, or in this problem, it tells us that we need to figure out at the end of one winter there are about 1.5 times 10 to the 7 squared kilometers of ice in the Arctic Ocean. By the end of summer, the ice has melted this is winter. By the end of summer, much of the ice has melted and there are only about 7 times 10 to the power of 6 kilometers squared at the end of summer. So we're trying to figure out how much ice melted. So to figure out how much ice melted, we would take the winter minus the summer, because we have how much we started minus how much we had left. That gives us the total of how much melted. So we can substitute, and we have 1.5 times 10 to the power of 7 minus 7 times 10 to the power of 6. You might say, oh, this one's bigger. How can we do that? But actually, this one's bigger because the power is bigger. So in order to do that, we need to change these both to have the same power. So you could go either way. Here, we're going to transfer this one to have the same power. So let's make it 15 times 10 to the power of 6. So if you move to the right, your exponent goes down one number. Remember, it's like negative. You could say that minus 7 times 10 to the power of 6. Now that they're the same, you could say 15 minus 7 times 10 to the power of 6 equals 8 times 10 to the power of 6. Remember to include your units, kilometers squared. That's how much bigger it is. Okay? Example 8. The approximate area of the Pacific Ocean is 6.4 times 10 to the 7 square miles. The area of the Arctic Ocean is 5.4 times 10 to the 6 square miles. You could also write square miles as miles squared. Okay. Let's figure out, this is the Pacific, that's the Arctic. Let's figure out the sum. So the sum, let's add them, 6.4 times 10 to the power of 7 plus 5.4 times 10 to the power of 6 equals, let's transfer this one. So if I move this one to the right, this becomes 10 to the power of 6. So we get 64 times 10 to the power of 6 plus 5.4 times 10 to the power of 6. Okay, when you move to the left, or when you move to the right, this goes down. If I were to move to the left, it would go up. So I could also say, if I wanted to move this one to the left, I could say 6.4 times 10 to the power of 7 plus, and then I move this one over, 0.54 times 10 to the power of 6. It works better this way because it's easier adding and you end up with a better answer. Oh, sorry, that's 7. Because we transferred to the left, so this went up 1. So left, up, right, down. Okay, but either way, let's start with this one. So we can say 64 plus 5.4 times 10 to the power of 6 equals 6.94, 69.4 times 10 to the power of 6. Is this scientific notation? No. So let's make this into, move it one to the left, so it becomes 6.94 times 10 to the power of 1 times 10 to the power of 6 equals 6.94 times 10 to the power of 7. So in this case, it may have been easier to do it with these numbers. You never really know, just pick one, and then if this isn't scientific notation, you would transfer it later. Let's find B, the difference. So we're going to subtract. Okay? 6.4 times 10 to the power of 7 minus 5.4 times 10 to the power of 6. That is equal to 64 times 10 to the power of 6 plus 5.4, oh sorry, it is 64. 64 to the power of 6, 5.4 10 to the power of 6 equals 58.6 times 10 to the power of 6, which equals 5.86 times 10 to the power of 1 times 10 to the power of 6 equals 5.86 times 10 to the power of 7. That is our answer. That is the difference. Okay. Notice these aren't too much different because this number is a lot smaller than that number by a whole degree. Okay, go ahead and try guided practice 3. Let's try together example 9. Example 9 says the standard CD is about 1.2 times 10 to the third meters thick. That's a CD. 7.0 times 10 to the negative 8 meters thick is a coating on the CD. So notice it's a lot smaller, but let's see how thick in total this is. That's A. We want to find out how thick in total. So we're going to add those, 1.2 times 10 to the negative third plus 7.0 times 10 to the negative 8. So we're adding them. This one is a lot smaller, so how do we transfer? Let's transfer this one to be negative 3. So this one will carry over. It will be 1.2 times 10 to the negative third. Now, if we want this number to be bigger, because we're going up to negative 3, if we want it to be bigger, we go right. So we want a bigger exponent, so we move the decimal right. Okay, let's practice that. So sorry, I said that wrong. We move the decimal left. Bigger exponent, we move it left. So we start with a 7. We go 1, 2, 3, 4, 5. Decimal place is here. The reason we did that is because 8 and 3 are 5 away. So we need to go over 1, 2, 3, 4, 5 to make it equal. So now it is times 10 to the negative third. And now we can add these. You can see how much smaller of a number this is than that one, now that we can compare them. So we could say to this, 1.2 plus 0.00007 times 10 to the negative third equals 1.20007 times 10 to the negative third. Add our units, which is meters, and that gives you your answer. Let's try B, which is how much thicker is the CD than the coating. So that's a difference problem. And we're going to put the bigger number, 1.2 times 10 to the negative third minus 7.0 times 10 to the negative 8. You already did the converting, so I'm just going to write that out again. 1.2 times 10 to the negative third minus 0.00007 times 10 to the negative third. This is going to equal 1.2 minus 0.00007 times 10 to the negative third, which is equal to 1.19993 times 10 to the negative third. Add your units, meters, and that is the answer. Go ahead and try guided practice 4. We are going to introduce the prefix system. So you guys learn this in science most likely, but I would like for you to look at it again. So you have this prefix system in the book. Okay? Your job is to memorize all of these. Okay? So memorize chart. Make sure you know that. Stars. Memorize it. You should know all of the ones in the book. There are other ones, you only need to know the ones in the book because it will help. For example, if the width of a human hair is 1.76 times 10 to the negative 4 meters. You could write that in other numbers, like 1.76 times 10 to the negative 7th kilometer. Notice the unit changed because a kilo is 10 to the third, so we changed by negative 4 to negative 7. So depending on which way you go, the number will get bigger or smaller. Here it got smaller. If you want it to get bigger from here, you go to a millimeter, it'd be 1.76 times 10 to the negative 1 millimeter. And there's different ways to go, and so on. We will learn how to actually change within these units, but for now I want you to memorize what they are. Memorize, for example, that kilo equals 10 to the third, because notice this change was 10 to the third because we went up on the scale, then this number went down. We can go back to our science notes to look at that if you need some help. Okay. Example 10. Add and subtract numbers in different forms. Here we go. A blue whale has a mass of about 190 million grams. The mass of the whale shark is approximately 2.6 times 10 to the power of 4 kilograms. Okay, so this is the blue whale, and this is the whale shark. Now, what is the approximate sum of the masses of the blue whale and the blue shark? Okay, you don't want to add them all like this, so we're going to find out their sums in an easier way. So first, write this in kilograms because we have to have the same units. Now, this number in kilograms, we need to go 3 to the left, so it becomes 190,000 kilograms, which is 1.9 times 10 to the power of 5 kilograms, because 1, 2, 3, 4, 5. And that is the amount of kilograms of the shark. So now we can add them, and the sum becomes 1.9 times 10 to the power of 5 plus 2.6 times 10 to the power of 4. Okay, let's say that is equal. We are going to, remember, these had to be the same. Units had to be the same, so I transferred to kilograms. Now that they're the same, I need to make the powers the same. So we are going to convert this 5 to a 4 by moving this one to the right, and so our exponent goes down, and it becomes it becomes 19 times 10 to the power of 4 plus 2.6 times 10 to the power of 4, which is equal to 19 plus 2.6 times 10 to the power of 4 equals 21.6 times 10 to the power of 4,